right, so I don't think there's anything else to stamp today. Am I up to date on stamping warm-ups? Okay, cool. So all you had last night was a concept builder homework. So this is a graphing warm-up. We did mathematical models. We did the worksheet last class. So I want to make sure that you get practice because we're having a quiz on it next class. We do. We have lots of quizzes in this class. And remember, the quizzes seem like they're worth a lot of points right now, but we do quizzes either every day or every other day, and so it's not going to be as heavily weighted the more quizzes that we do. If you need graph paper, I've got graph paper up here. This is a graphing activity where you're going to create a mathematical model. You're going to eyeball your line of best fit, so you're going to use a ruler to do that. And you're going to calculate your slope. You all did practice calculating your slope. I had some students say, I know how to calculate my slope. How come I keep getting these wrong? Turn your slopes into decimals. And it was the same for the homework. You have to turn your slopes into decimals. So, yes, pay attention closely. We're going to do, very generous. I'm going to do a quiz next class on mathematical modeling, where you're given a set of values and you have to graph, estimate your line of best fit. So everyone's going to eyeball it. Am I going to grade you if you have the exact same slope as the one that we have up here? You should be close, but it's not going to be exact. We're all eyeballing things in this next quiz. And then to write your mathematical model doing the 5% rule and calculating the slope. You have your equations, like I said in your physics helper. Your slope equation is right here. Your steps to writing out the mathematical model is right here. Your 5% rule is right there. And in this box, there's a reason why it's boxed. It's because students always forget that one part, where to include the variables and when to include the units. So let's go ahead and walk through this together. The first thing we want to do on our graph, guess what I'm going to check? Do you have your axis labeled? And Ava did exactly that. She put pressure and depth, and then your unit should be in parentheses. I think she forgot her second parentheses, so I would take off points for that. I'm just kidding. I won't take off points for something small like that, but if you don't put the units at all, yes, you will get docked points. The second thing I'm looking for is that you label the intervals of your axis equally spaced apart. Okay, so Ava went by 20s on both sides. You can't go by 10s and then skip and decide to go by 20s just to make things fit, okay? Equally spaced intervals. Next, you graph your data and you draw your line of best fit. So Ava did the best she could and tried to fit it across most of her points or in between the points as best she could. And then from there, we have to decide how we're going to figure out what our slope is. So this is a common mistake. My equation for slope is equal to, I'm just going to get rid of that for a second so you can see. Slope m equals y2, minus y1 over x2 minus x1. So if I'm looking at this data here, I shouldn't have done that. If I'm looking at this data and I'm trying to choose points for my y1, y2, x2, x1, which points am I going to choose? Can I just choose any points? Would I choose this point? Definitely not. This is the one point that looks like it's way off. Would I choose this point? If you guys can see it. Right here? No. I want to choose a point that lies on the line. Another question. Do I have to choose a data point on the line? Do I have to choose a data point? Does it have to be on my data list? What if my data points look like this. Over here, a little up there, a little down here, here, and here. What if I didn't have any data points that hit the line? Would I choose a data point? No. So what the common mistake students make is that they choose points on the data table, even if it doesn't land on the line. If you draw a line of best fit, you want to go through the center of your points, which means that it may not hit any of your points at all. So your goal is to choose points on the line. And it doesn't matter if it's on your data table or if it's just a really nice point that is easy to find the number values to. It has to be on the line. So, easiest way to do this is actually, because Ava was able to find points in her data that fit a line of best fit, I'm going to choose this point right here that looks perfectly on the line, and I'm going to choose the first point right here. So what does that give me? That gives me 60 and 40.5 and 0 and 15. So I'm going to do the calculation. Actually, can I have someone calculate this for me just to save me time? 40.5 minus 15 over 60 minus 0. 0.43. Okay, what am I missing here? Another common mistake. Great. Units. Anytime I do a rise over run, I always include the units. My units for my rise is pressure, or you can look here, it's pressure. But I'm not going to put pressure, I'm going to put pounds per inches squared. Another way to call pounds per inches squared, for those of you who like to work on cars or pumped up your bicycle tires, PSI is pounds per square inch. So you can use PSI. For depth, it's in feet. So in my final answer, I'm going to write PSI over feet. That's my slope. Okay, in your physics helper and in your quiz, it's going to say walk through the steps starting with y equals mx plus b. Notice how they have those arrows where it says x variable, y variable, slope, y-intercept. For a lot of you, doing this step is going to make sure that you have all the appropriate values. For some of you, you're like, oh, that's so repetitive, I don't want to do that. If you feel like you don't need to, that's fine. But if you feel like you want to go through the steps just to make sure you don't miss anything, I will actually give you points, I don't know how many, let's say +0.5, just for writing down y equals mx plus b. And then writing out what each part represents. Y variable, slope, x variable, y-intercept. Let's say that's another half of a point, or half. So just by doing this, which is literally copying your physics helper, you can get points for that. If you decide to skip it and then you just give me the mathematical model, I'll give you all the points. You don't have to do these steps. But if you make small mistakes like most of us do, I suggest you do this. Okay, now we get into the actual mathematical model. My y variable is PSI, pressure. Remember, variables are the ones that are not in parentheses. My slope I calculated to be 0.43. And then my x variable is depth. And we're multiplying it. So times depth plus my y-intercept, which is easy because it's actually on my on my data table, 15 psi. So this is what I have so far. Would that get full credit? What am I missing? My units. All number values have to have units. So don't forget your units for your slope, and don't forget your units for your y-intercept. And in your physics helper, it's not only there, but it's also boxed. So it tells you, don't forget your units. Do I need units for pressure? Do I need to put units for my variable? For pressure depth? No. Because you're just going to create more confusion if you put pressure, PSI, and depth feet, and then you also include units here, so only include units for number values. Last step, which Diego did for us, is to do our 5% rule. So Diego got his y-intercept, 15. He also took the absolute value because students think if it's a negative, then I automatically drop it. That's not the case. Always take the absolute value. 58 is the max y value, so that's my value on my y scale. And then I multiply it by 100 to get a percentage. So this is my ratio, and this is my percent. Am I going to keep or am I going to drop my y-intercept? 25.86%. What does your physics helper tell you? Keep or drop? Keep or drop? Should be obvious. Keep. So this is my final answer. What if instead of 25.8, I got 4.9%? What am I going to do then? Drop it. What if I got 4.9999999%? Drop it. What if I got 5? Keep it. If you got 5, I would probably say keep it, but if you dropped it, I wouldn't dock you too much. I want you to make sure that anything less than 5%, you drop it. And if you dropped it, you would stop right here. Pressure equals 0.43 psi over feet times depth. How many of you got something relatively close to 0.43 in slope? It doesn't have to be exact. It should just be close. If you got 1, or if you got 0.2, or a negative value, then you would definitely get points off. But if I can see that you did the work right, you chose appropriate points, and you got something relatively close, I'll give you the points. Let's go over, and you'll have a little bit of time to add more to your worksheet if you need to. Well, let's go over students' answers. For the slope, I've got 9.77, 9.8, pretty close. I have negative 130, so let's put a little kind of star here. We're going to look at that in detail. Don't worry if you got it wrong, because we're going to talk about sources of error. 8.65. It's not too far away from 9.8, so I'm going to go ahead and give that a check mark. Negative 5 is probably further away than I'd like it to be. Same with negative 0.78. 8.9 is, 8.9 is actually not too far. And then negative 9.99 is pretty close also. So I've got some number values here that are relatively close in value. Negative 9.7. I got a 2 for my last class as well. Negative 9.8. Same with this one. I got negative 9.75. I had 3 from my previous class. I have 5 from this class. So you guys did pretty good. Better than my last. But I also got a bunch of these outliers. So we're going to talk about the outliers. Can anyone tell me what the actual value for my gravitational field strength is for Earth? Rachel. Negative 9.8. Why would it be negative? Why do we have negative values? Why do you think we have negative values for our gravitational field strength? Gravity generally pulls us down. When we talk about the force of gravity in our force-fighting diagram, it always points down. So that's why we have this negative sign here. So the actual equation, and this should be similar to what you wrote, you have a y-axis of the force of gravity, we call it the force of Earth on the object, equals the slope, and I love how you guys included the units here. It's newtons per kilogram times the mass. Another word for the force of gravity or the force of Earth, we call it weight. When we weigh ourselves, we use the unit of pounds, but when we're talking about physics, we always use N for newtons. That's our unit for any sort of force, including the force of gravity or weight. Okay, so we've got a bunch of good values here. Negative 9.77, negative 9.8, negative 8.6, that's not too far off, negative 9.99. So let's actually talk about where our errors might have happened in some of these data points. So this is where I want you to pull out your purple sheet. When you write a CER, and I'm actually not going to assign the CER, we're going to do the CER as a class, simply because you just turned the CER in. We're falling a little bit behind, and I just want to make sure that we catch up, so we're going to do the CER together. First thing is when we do a lab and our numbers are perfect, we need to talk about sources of error. And even if you got negative 9.8, even if you were group number 7 and got your slope spot on, you might notice that your dots were not perfectly on the line. Group number 7 was every dot falling on that line. Oh, dang, you guys are good. All right, so with the exception of group number 7, we're going to have a little bit of source of error, even from some that are really, really close. So let's look at our source of error. This is what you would do for a CER. There are two types of error. One, we call it systematic, meaning there's a pattern. Either all your numbers are too high or all your numbers are too low. So if I look at some of these values, like negative 130, negative 5.5, or negative 0.7, look at your graph. Does it look like the points fall along the line pretty well for group number 6, 2, or 3? Or did you have some big outliers? How many of you had dots that actually fell on the line even though your slope was way off? Any groups that had a slope way off? Group number 2? So this one probably was a systematic error. If it looks like they made the right pattern and there were no big outliers, then there probably was an error either in your instrument, maybe you didn't calibrate something correctly, maybe you included the weight of the string or whatever it was that you were trying to hit your object from, but it means that your numbers were consistently too low in this scenario. So systematic errors, they could be instrumental, like I said, you didn't calibrate, or it could be your scale was just off and it didn't calculate things right and it was consistently too low. Observational, they have an example here. If we're measuring things and we're looking at things at an angle, it's always going to be either consistently too high or consistently too low. Environmental, if we have wind blowing in and it threw off our data, usually it's random, but if it was consistently throwing it off to be too high or too low, that's systematic. And then theoretical, this would be something like, let's see, when you're approximating number values. If you round it, you might round it and your number values are consistently too high because you're not using enough sigma. So those are the types of things where you've got systematic error, where there's a pattern. Random would be, were there any groups that got number values and they had a really large outlier, or maybe several large outliers. Anyone for group number 6 and number 3, did you guys get big outliers? So that would probably be a random error, meaning something in your environment or maybe your instrument decided it wasn't going to work for you and it gave you the wrong value. So random error would be probably, for group number 3, you would probably call that an instrumental error because you said that your scale wasn't working very well, right? Environmental, again, wind blew through the window and it caused that one piece of data to be way off. The other ones, blunder. If you had a big outlier, it could have been because you just forgot to round that one number, or you didn't round it correctly, or you just reported it with the wrong value. That happens, so we call those blunders. You never call things human error. You always want to identify what type. And then modeling error is when all your data is clustered closely together. And I think I had group number 1. Did you guys say you had a lot of data clustered close together and then one that was way off? That's what we call a modeling error. You generally want your data points to be pretty spread out. If they're all clustered together, it can throw off your slope and your accuracy. So this is something you're going to use in the next CER. We're going to write this CER together. Before we start, I had some students ask, how do we write a for every statement? Your for every statement stems from your slope. So whichever slope you have, you always start with your x variable, the variable in the denominator. And you write for every 1, because your denominator, if you turn it into a fraction, is over 1. So for every 1 kilogram of mass, my, or the force of gravity increases, what should I say here? Increases, decreases by 9.8 newtons of force. So this is the type of for every statement you want to write. And all it does is it gives context to your slope. For every 1 kilogram of mass, my force of gravity decreases by 9.8 newtons. A more accurate way to say this, pulls downward, 9.8 newtons. So that's another way to state it, probably more accurate than decreases, pulls downward. Okay, this is how I would write the CER. And you're going to have to write a CER for a future lab using data, so I want to make sure that we follow along closely and know how to do it with this one, even though you're not technically doing it for homework. So when I write a CER, first of all, let's go over mass versus weight. Mass stays consistent, that's why it's our independent variable. Weight changes, and weight is also dependent on 2 things. It is dependent on your mass and where you are. So your gravitational field is what creates that downward pull. On the moon, it's negative 1.6. Here on Earth, it's negative 9.8. And when you look at your physics helper, we write the equation out as mg. G represents negative 9.8, so you're going to end up memorizing that because we use it so much. But it's in your physics helper right here. Force of Earth on object is negative 9.8 newtons per kilogram times mass. Here I wrote it out as mass times negative 9.8, mg. Your unit for weight is in newtons, as I stated before. And we just proved this CER. I meant to do the reasoning with you, but I did it with my fourth period, so I figured let's go ahead and just do it together. We have to prove the entire equation. So we need to prove that force of gravity is our dependent variable, our y variable, and that our mass is our independent variable. So we're writing that as our evidence. Our reasoning is based on the fact that mass is the same anywhere. We already talked about it. It doesn't change. It's the amount of matter we are made out of, and it stays the same whether I'm on the moon, down deep in the ocean, or up in outer space. Force of gravity depends on location. It also depends on mass, but we didn't talk about that until after we had solved this equation here. So it depends on location. The second piece of evidence is your graph. So you're always going to want to use the graph created by your website because the hand-drawn ones aren't going to be accurate. But I would literally cut and paste this onto my CER and say, this is my evidence. Evidence is an observation or it's data. So from that piece of evidence, we have our slope. We're going to say our slope. For some groups who got pretty close, you're going to say the slope is 9.7 based on your graph. For the students who didn't get close to negative 9.8, guess what? You have a lot of data from the entire class that show negative 9.8 is the correct slope. So you can say we didn't get the right slope because of a blunder, but 5 groups in our class got something close to negative 9.8. So that would be some sort of evidence and reasoning, even if your slope was not accurate. And then you would want to talk about why. Why is your slope negative? Well, because of the force of gravity pulls down, and the values you got from force on your force sensor were all negative values, right? And then the last part, so we proved, I don't have my clicker anymore, but we proved the first part, we proved the x and y variable, we proved the slope, we proved the negative sign. Now we need to prove why there's no y-intercept here. How many of my groups that got pretty good data said that they had to drop their y-intercept based on the 5% rule? So I have 2, 3, 4. This group, you didn't drop it, but your 5% rule was really close, right? It was about 5.8. 5.38. So group number 1 actually got a 5% rule that they didn't drop, and it was pretty close to 5. And so most of our groups that got accurate data said that they dropped the y-intercept because of whatever your 5% rule gave you. Based on the 5% rule equation, our value was 2%, so we dropped the y-intercept. And then the error analysis, we already talked about it. Depending on what your data looks like, it could have been a blunder. It could have been a random error because your instrument didn't work. It could have been a systematic error because you didn't calibrate your instrument. And even if you got a value really close to 9.8, I still want you to talk about sources of error in your CPR. Any questions? Okay. We've still got a few minutes left, about 10 minutes left. Your homework for tonight is to do a mass versus weight physics Canvas homework quiz. So you're going to use this equation, negative 9.8 times mass, and you're going to study for your modeling quiz. This homework is actually pretty quick.